Yes. BGP configuration. You see, this blue one is a big autonomous system which has got one, two edge routers and many inside routers. Many inside routers. And we got another autonomous system here in the left, another one over the right. Now the right hand side autonomous system has got some networks. So we got autonomous system 10, let's say, autonomous system 20, and autonomous system 30. Now we know the problem in BGP that route learned from one IBGP will not be given to another IBGP. To overcome that, we used to do full mesh or we used to do route reflect. So let's say you did route reflector here. No need. Why to reflect here? You do route reflector here because the route learned from here. No, what I did is correct. You do route reflector here, so that route learned from here will be given here. Then again, you need to do another route reflector to reflect here. That will be too bad, okay? Too many route reflectors. You understand what I'm saying?
Yep.
Let's say you got another route reflector here. Is this enough? Not enough. Whatever comes from here will go up to here. Whatever comes from here will go up to here. And later on, no communication, no distribution of route. So again, you will put one route reflector here, so it will go up to here. Again, you need to put another route. That is not practical. Too many route reflectors. So they try to reduce the route reflectors by creating sub-autonomous systems.
Is the video start?
Yes.
Oh, okay, okay.
So they decided to create a sub-autonomous system like this. Why? Why do we need sub-autonomous system? So that these two routers, which two routers? This and this. These two routers will think that they are EBGPs. And originally they belong to same autonomous system. But we create 6549. 65549. Sorry, I don't have 49 at all. 65449. That's what I want to write. 65450. A private autonomous system. This is called 5122-65535. So that's why I took in that range here and here. So we use a private autonomous system number so that this two router will think that we are EBGP, and the route that was given to this router, now it will be giving it because it is EBGP. And the route now learned from an EBGP will be given to IBGP. Route learned from an IBGP will not be good, so okay, you need to put another RR here. There is no other go. You cannot create more configuration also. But we avoided at least 2 route reflectors by creating configuration. Let me make the topology simple. I think the topology I made is a complicated one. Let me make it simple. Okay. So we do one RR here, one RR here. That is enough. You don't need any more RR because you got confederation providing EBGP relationship here between the private autonomous system. That solves the problem here. But we are not doing these things. We are not creating confederations in the real world today. The reason is MPLS. We do MPLS layer 3 VPN. In here, without MPLS, we are trying to distribute the, let's say this is customer. The customer's route we are giving to every router, and every router routing table learns it, which is unnecessary. Customer 1 wants to reach customer 1's remote office. Then why do I need to learn customer's route? Not necessary. So what is recommended to do is to do a VPN between the provider router. Forming a VPN avoids enabling BGP on this router. So there is no need for BGP at all. So no need for route reflector, no need for configuration when you have MPLS as a solution. Anyway, sometimes people will not be willing to do MPLS. I have seen in some trainings, particularly one training in one African country, I told, actually it was a BGP training. And the training was almost done, so there were some more hours left. I was trying to teach them MPLS. I said, you see, learning MPLS is the next step. And I was explaining what I am explaining now. If you put VPN tunnel, then there is no need for BGP on all these routers. Then what they did, what they told me, they say, no, sir, no, Jay. We don't want MPLS. We are not going to enable MPLS in our network. We don't need MPLS. Simple. I was trying to help them. I'm not going to charge them for that. They know it very well. But they said, no, Jay, we are not going to enable MPLS. We don't want MPLS. They're not even ready to learn it. For such customers, this configuration knowledge is important. Route reflector is also important. Configuration is also important. So about route reflector, we have learned that route learned from one client will be given to another client. Route learned from one client will be given to eBGP. Route learned from one client will be given to the non-client, which is a passive client. But route learned from one non-client will not be given to another non-client. All those the route reflector thing we have learned in the
Yes, yes,
past. Do you
yes.
remember them? Yeah. So keeping all those things in our mind, we are going to do this lab configuration. Before
No,
we go get into
not
the lab,
yet.
do you have any question? So what is confederation? Tell me,
Confederation.
please.
Yeah. Confederation is a way
Confederation, confederation.
to provide or eliminate some of the road reflector that would be in a network by, say, creating internal AS as private AS, so the route from, so they can see each other as eBGP instead of IBGP. So the route from, say, a group of router would be go over to another group of router inside those private AS. But the entire AS is a big AS, so it's like AS within AS.
Yeah. So I'm going to take router 1, 2 as the external autonomous system member. 3, 4, 5, 6, 7. So usually we used to take 3 routers in this middle to test. Now I'm going to take more so that we can have some sub-autonomous system. Okay. Now let's connect the cables. I'll use serial to the outside autonomous system. And for all the rest of the thing, I'm going to use fast Ethernet. Right. So, right. So now, as we spoke earlier, we are going to have this as autonomous system 10, and this as autonomous system 30. And middle one is autonomous system 20. So this is the original
Right.
autonomous system. Autonomous system 20 is the original one. Right. Let us quickly put the IP addresses on those interfaces, and then we'll begin. I'm not going to write too many numbers
Right.
here because we
No need.
usually do like this 10 dot,
No need. That's just
13 dot. Yeah. And also, I'm not going to say the loopback interfaces. Every router will
yes.
have loopback interface with the
Right.
router name. For
Right.
example,
That's
router
okay.
5 will have 5.5.5.5. So let us begin configuration.
Let's use Notepad.
You want to configure? You can jump into your device if you want.
Yes.
Or I'll do it, but you can do it later. Yeah. Because sometimes you will feel the slowness. You told me on the other day. You feel slow. Okay. Next is the notepad. I'm
Right.
also going to do BGP configuration along with the basic configuration. Enable anything else?
No, if you say no, this exit won't work because this exit we care about to the global configuration. So I just put end instead.
Right.
Oh, you're pressing router 2.
I pasted on the wrong router. Yeah, that's okay. I can change it. So router 2 configuration
And interface
is like
3.0.
this.
3/0.
Hmm.
That should be 2.7.
See, there is no change in the configuration on R1 and R2 when you do configuration in the core. So customers no need to worry about any extra thing because they will not
The
know whether you use
remote AS so
configuration or
should be.
MPLS.
Oh yeah, it's good.
They
It's
will.
good.
The reason why I gave this router ID is router 2 might have already picked the Lubac 1111 address which I pasted earlier as the router ID. So I'm saying use this. I'm seeing an error message.
Oh.
Yeah. First I need to remove the old BGP. Okay, so no need of this one then.
Right.
You cannot have more than one BGP. So I'm saying no router BGP 10. Okay, now show IPBGP.
Yeah.
I want to see the router ID. Okay, 222. Perfect. Now let us go configure R7. I'm not going to configure configuration right now. I'm doing normal BGP, and I'll show you the problems, and then we will introduce route reflector,
Configuration.
and then I'll show you that route reflector is also not sufficient. Then we will remove that BGP and put configuration BGP. The configuration will be totally changed. So let us first start from what we know. MN router 7. This is 27.7, and we also have another interface
0, 0.
F. That will be 1067.7, and then here I would like to run OSPF.
Don't need for that.
0. 37003. Sorry.
We gotta fix that.
Oh no.
37. Yeah, we can fix
I
that.
think on
That can
router 2
fix.
I have put 37, which is wrong. Oh, come on. Okay. So going back to this, this is 27 dot. I don't want to advertise any network here, so remove this. There is another IBGP 10.67 0.6
But this the top one to
remote
be remote is
is
30, isn't that right?
20.
The one 27 should be remote is 30.
Okay. Yes, you're right. Sorry. Okay, we go with this on R6. Next. Sorry, did I paste in R6? Oh no, I should have pasted in 7.
Yes, you should paste that in 7. It should be in 7.
Yeah?
You know,
I mean,
we have too many tab open up. Just open a tab that we need.
it's okay, don't worry, I will fix it. This is going to be 6.6.6.6. And this is F.
Shouldn't be running OSPF on that.
0. And then this is 67.6. 0. And this is 56.
That's 6.
Dot 6. And then BGP, only IBGP 1056.5.
Next one down here is that 7.
And 20.
7.
1067.7.
That should be good.
20.
And router 6.
No, there will be issue with the router ID. We'll fix it. Show IP protocol. I want to see what router ID OSPF has taken. Oh, good. It has not. It has taken 77. I have to change it to 666. Router OSPF 1. Router ID. Okay, now show IP OSPF interface brief. OSPF is not running on this interface
01.
F. I should put interface
01. Should be there.
F.
Because it's there.
F1/0 also got it. You know why I don't see? Interface F1/0 IP OSPF1 area 0. But there is no IP address. How come? IP space address. Looks fine. Let me try to paste. Something
They
is
do an
wrong.
interface brief. Show IP.
It's slow. Okay, 1 minute, 1 minute. (56.005.20) 5067.007.20 looks correct, but it says BGP identifier
Just
is
put
wrong.
just a hardcore BGP
Why?
router ID.
Correct. Router BGP 20.
666.
BGP router ID.
Came up with 7. No.
Yeah, 5 is not yet configured. Now let us do the router 5 configuration. 5, this is going to be 1/0 and it will be 5 here, and this is going to
56.
be
No. Wait. Now you put it.
56.5. 54
Yes.
dot 45.5, and this is 56.6,
4, 5,
45 dot
4. Wait. Is it 40 or 40? Oh, this should be 4 right now. So 45.4.
all right.
Router 5.
This will
Yes,
go on
router
router
5.
5, am I right?
Neighbor with.
We are expecting
Yep, it's there.
OSPF neighborship and BGP
Router.
neighborship. Okay, both has come. Now one last,
So
two
router
more
4.
routers. It's the same
Okay.
topology we'll be using for MPLS topic later. And this is one. For and then 00,
34.
there's 34,
4.
4, BGP 34,
3.
3,
Oh, 5. Where's
45,
5? No, you can't have 5 there. Because we're in router 3. Or router 4. Which one are we in? Oh, okay. Yes, that's right. I'm
you're in
sorry.
router 4,
4.
sorry. Now we go to router 4. So we are expecting one OSPF for BGP. Okay, it has come.
Router 3.
Now this is the last router. 3.3.3.3 and F0.
Yes, 0, 0,
This
3,
is
3,
serial
1. 3, 3, 0.
3. No SPF 13
3.
3.
34, 3.
F00 is 34 3. And then
34, 4.
BGP neighbor is 13
And 10.
1 and 10.
34, 4, 4.
And this is 34 4
This would be good.
20. Neighbor
8. Oh, we have 2 neighbors.
10.34.4.
Oh, okay.
Next hop
We didn't do that in router
self.
7.
We'll do it. Route 3. Now on R7,
20.
router BGP neighbor right. So we even given the next hop self, but routes are not going to be distributed. If you see the routing table of router 1, show IP route BGP,
Sharpie BGP.
no routes. Actually router 2 is advertising show IP BGP, you see. Router 2 is advertising, but router 1 is not learning. Likewise, router 1 is also advertising. Router 2 is not learning. Let's troubleshoot.
Oh, absolutely.
Will it be seen in router 3? Yes. Show IP BGP, but router 3 don't have 2222.
No,
What about
nothing.
router
Because
4? Router 4 will
road
not
from
have
1
anything.
IBGP will not.
No. Router 4 will get it. Router 5 will not get anything. You see, show IP BGP. Router 4 has got it,
Next
and it
up,
is also
self.
valid at best because we have the next hop self command. Likewise, router 6 will also have 2222,
Alright, that's
but
where it broke.
router 5 will not have anything. So what are we going to do? Let us do one route reflector at least.
From router 4.
Let
From router
us
4,
reflect
yes.
the route till 5. Yeah. Router BGP 20. Neighbor 10.45
Reflector client.
5 is the route reflector client. After I say this, you will find router 5 show IP BGP having 1.1.1.1.
Okay, let's see what happened to router 6. Let me get it.
But but router 6 is not giving route to router 5. So if you go to router 6 again and say
Do I show IP BGP and
router
see if
BGP
5 send the route to router 6 at 1.1.1? No.
it won't. It won't. It won't. We went to router 4 and we said I want to reflect to 5.
Right.
5 is a client.
Will not
Why will it
client.
it send to a non-client? It won't send. Router BGP 20.
Neighbor.
So we are going to say you reflect to 5. Neighbor 10.56.0.6, sorry, 5 is a now router 5 will have both. Router 5 has got both. No. What about 4?
Still don't, I know.
Show IP BGP. You don't.
Definitely not.
What about 3? Definitely
only 1
not.
or 222.
What about 6? So route reflector is not a complete solution. It can be used along with confederation, or it can be used along with MPLS VPN. But MPLS VPN is not our focus now. That is our next topic. So with what we know, we need to provide solution. We cannot keep configuring clients, route reflector clients everywhere. That's not good. The reason is it will increase the we call it as route reflector boundaries. If they are all overlapping, sometimes they will cause loop in case if there is another wire between R3 and R5. In our topology, it's not going to cause. They form cluster actually. If, for example, if you go to router 5 and check, hey, what is your cluster ID? It will say 4.4.4.4 and 6.6.6.6 are cluster IDs. Let me show you. Show IP BGP for 1.1.1.1. It will say for this, the cluster ID is 4.4.4.4. Yeah? Because this is the guy who is reflecting. So that is the head of the cluster. Okay. Now for
yes,
2222, do you understand what I'm saying?
666 is a cluster.
For 2222, 6.6.6.6 is the. Now if I configure route reflector client on 5 also, then it will be too many clusters overlapping. And when we have a redundant path, then it will cause loop. Right. So not a good idea. So we are now planning for configuration. You know what? All the BGP I configured now, I have to remove. Yes. I'm going to remove BGP from every router.
AS20.
Between R3. Yeah. You're right. Okay, I'm going to start from router 3. Okay. Now, as I spoke earlier, we are going to create some autonomous system. Now, what I'm going to do is, I'm going to group these three in one autonomous system.
Make the next circle, make the back circle a little bit bigger.
And I'm going to give a number 65431. And this is going to be another group. So that this router 5 and router 6 will consider themselves as eBGP. But originally they all belong to autonomous system 20. That is not going to be changed. This is just a private AS. So let us do the configuration now. I'm going to router 3. As usual, you configure router BGP 65431 and then neighbor 10.34.0.4. Remote AS
Same.
is again
Yeah, but you have to go change our router one
65413.
also. No, we don't have to. No. Yes.
No.
But it's
See,
still
according to
AS20.
router 1,
Yeah,
they are,
yes.
yeah. So if you now configure router 1 as a neighbor, it will start throwing error.
Yes, this shows.
AS mismatch, isn't it? Router 1 thinks that my neighbor is 20, but this guy is going to say, no, I'm not 20, I'm
Yes.
65431. You understand? To solve the problem, first you need to tell what is the original autonomous system this router belongs to. The command is this: BGP configuration ID is 20.
Yes, it is.
This is the important command. And then you say, I have a neighbor 10.13.0.1, remote AS10. Now router 1 and router 3 won't have any problem. They will not have any problem. They will not, router 1 will not complain saying there is a conflict in router ID. Sorry, it won't say there is a conflict in autonomous system number. Because router 3 is identifying itself as 20 when it speaks to router 1. But when it speaks to router 4, it uses 65431
Yes.
because they all belong to same group, same sub-autonomous system. What is next?
Next
What
is go
is
to router
next?
4.
What is next? Nothing. That's all. Let's show run section router BGP. I can see router 1 and router 4 properly configured. Likewise, I would like to finish router 7. Router BGP 65432. Yeah. And I'll say BGP configuration ID is 20. And neighbor 10.13.0.1
27.
Is it 72 or 27 eBGP? 27.0.0.72. Remote AS is 30. Another neighbor is 10.67.0.6.
65432.
Remote AS is 65432. Okay, and now very important is the next up self command neighbor 10.67.0.6
We didn't do it on the
next
router
hop
3.
self, which we forgot on router 3. Done. Let's go to router 4. Router BGP 6531 neighbor
34.
10.34.0.3.
65.
Remote AS is this. Another neighbor 10.45.0.5. Remote AS the same.
Yes.
And we want to reflect the route, isn't it? So neighbor
Route reflect
10 dot
client.
route reflector client. Now let us see whether we are learning route in R4. Show IP BGP.
Yes.
We do learn it. On R4 we are learning it. Now let's go to R5. Router BGP
No.
6541431. Neighbor is 10.45.0.4.
6.
Remote AS is this. And I got
Turn
another
on
neighbor which is
56.
10 dot
That's 0.6.
56 dot 0 dot 6. Remote AS is plus
Yes.
1, isn't it? 32. And now let us see whether we are learning route. Show IPBGP here. Yeah, we do learn. Let us see the cluster ID. Show IPBGP 1.1.1.1. We can see router 4 is a route reflector server. Okay. Now, going to router 6. Router BGP
65432.
65432.
Neighbor.
Neighbor 10.67.0.7. Remote AS is same. Neighbor 10.56.0.5.
1.
Remote AS is 1. Now we are expecting neighbor. Okay. Now on R6, let's see whether we are learning route. Show IPBGP. We are learning both.
Well, 2.2
We are
is
learning both.
Yes, we are.
Okay, so router 6 says, I'm learning this from this particular sub-autonomous system.
Let's go to router 2 and
Number.
see if we're learning
Yeah,
the routes
it's
also.
sub-autonomous. Wait. You have to check many more things. Let's go to router 5. Show IP BGP. Here it says I'm learning 222 from router 6 and blah blah. Now let's go to router 4. Show IP BGP. Here also you are learning and the same private number is shown. Let's go to router 3. Private number is shown. Okay. Now show IP BGP. It shows both the public and the private.
Can we ping? Oh,
which is not acceptable. Wait,
which is not acceptable.
you're jumping too far. Please wait. Now let us go to R7. Show IP BGP. Even here I see private. Let us now go to router 2. Show IP BGP. Here also I see private. See, you will definitely ping. Pinging is not our aim. We are doing this ping for a long time. We are not new to BGP. All right, pinging will happen. No problem. Confederation, is it working? Of course it is working. But is this acceptable? Revealing our private autonomous system, is it acceptable? How do you prevent this? Has the Confederation done? Yes, Confederation is working. Otherwise, we will not be able to ping like this if Confederation didn't work. We didn't have much route reflector, only one route reflector. You need at least 2 route reflector for this to happen. We had only one. We have only one. We are able to ping because it's Confederation. R5 and R6 is not having IBGP kind of relationship. So we are able to ping. Now, how do we filter this private autonomous system? Now, tell me where all we have typed this command BGP Confederation ID. Let us try giving that command. So far, we have not given that command in any other router. Let us try giving that command on 6 and 5 and see what happens. Router 6. Router BGP 20. Sorry. Router BGP this. BGP Confederation ID. That is true. Router 5 and 6 do not know that they belong to 20 originally. Isn't it? That's why let us try giving that. To bring it to the knowledge of router 6 that you are not an ordinary guy. Let's go to router 5. Router BGP Confederation ID
20.
20. So we have done this on 5 and 6. Let's see whether there is any difference. Clear IP BGP star soft.
By that curl is
pairing with wrong AS. Yeah. Of course. Now router 6 says I belong to AS20.
Yes.
Router 5 says I belong to So that command is not a
Right.
right command to
Only.
be typed inside.
Right. So just put it on
So
the
that is
edge.
not solving the problem. Okay, so configuration ID command will not solve the problem. Which problem? Hiding that private AS.
Should be able
So
to
there should
suppress
be
AS.
another
I think I've
command.
read it somewhere. You can suppress AS.
Yeah. Yes. Okay, what are all the other solutions we have for suppressing the private AS? So I'm going to go to router 5 and configure configuration peer. Router BGP 65431 neighbor 10.56.0.6
Same
conf
router.
no uh, BGP configuration peer is the other autonomous system number. Likewise, I need to go to router 6,
Oh, the internal edge.
router BGP, yeah, and say neighbor, not neighbor, BGP configuration peer is this. Okay, now clear IPBGP star soft. Clear IPBGP star soft. Now let's see whether the problem is solved. I'm in R5 already. Show IPBGP. Here it shows. Now let's go to R4. Even
The
here in
internal.
R4, it's okay because in R4 you can.
Oops.
Now I want to see in R1. No difference. Not even in bracket. In some operating system, it used to show in brackets. Okay, so not even in brackets it shows. After show run section router BGP. Yeah,
Right.
here we have given correctly. So after giving this command, we don't see any difference. It's same like before.
Right.
So this is not the solution. This is not one which is a solution to our expected result. But for my satisfaction, I'm going to do a hard reset, clear IPBGP start. Go and check now. I'm waiting for 222 to come now after doing the hard reset. Even now, there is no change. There is no change. Okay. Let us try giving that same command on router 4. Router BGP 65421 BGP confederation peer is who? Clear IPBGP star soft. Will there be any difference now? Right.
No.
There's no change. So what is left is I did not put that command in 3 and
Sure.
7. Let's do that. Router BGP here. BGP configuration peer. Nothing wrong in telling this. You have another peer. Configuration means private
Right.
autonomous system peer. That's the meaning of it. Okay, and R7 router BGP. You are the configuration peer for this guy. Clear IPBGP star. We are refreshing the routes. Let's see whether this works. Going to router 6, show IPBGP.
To come back up.
Let's go to router 1.
Nothing.
Uh-oh,
Oops.
I cleared again.
But still
I
nothing.
cleared again. Okay, anyhow, you can see that there is no change.
I read somewhere where you can.
There is no change. So
Right.
before we send the route out, we need to put the eBGP neighbor address. Router BGP
That's
65431
it. Neighbor.
neighbor 10.13.0.1
Private A. Yes. Yes.
remove private AS. I'll do the same on router 7. Router BGP 65432 neighbor 10.27 0.3 remove clear IPBGP star soft. Clear IPBGP star soft. Now if you go to
Oops.
here, clear IPBGP star. Let us wait for the hard reset to do its job. Show IPBGP.
Still Oops.
So it has come here, it will come here also. Okay. Now let us go to router 1 and see.
It didn't work.
The command did not work. So